Welcome to this Quick Start Lab on Kubernetes Engine. My name's Jim Rambo. I'm a curriculum developer at Google, and I'm delighted to get this opportunity to show you our product in action. Before we start, let's just take a minute for a quick review. Containers are a packaging mechanism for building containerized applications abstracted from their environment, so they can run anywhere without any configuration changes. This provides separation of concerns, so developers can focus on logic and dependencies, and operations folks can focus on application deployment and management. Kubernetes runs containerized applications at scale. It's open source and is a container management platform, so it provides abstraction over the physical infrastructure. It handles the compute, the networking, and the storage so the containers can talk to each other. And it provides primitives for machine cluster and deployments, that's your application, and services, which are your endpoints to your applications. It also provides updates and monitoring. In other words, it provides your complete continuous integration and continuous deployment pipeline. By now, you should be at this page. You can reach this from the reminder email or click the link in the blue bar below the video player. So let's get started. I'm going to click Get Started, just as you would. And this will ask you for a code. You should be able to get this code from your email. This gives you access to the free resources of this environment inside of Qwik Labs. Now you may see the Qwik Lab page show automatically, or you may need to go back. You may get a list of labs here. If you're having trouble finding it, just enter in Kubernetes Quick Start in the search bar and the lab link will show. You can click the lab link and then you will get to the lab page where this lab can begin. To start the lab, you click Start. Notice there'll be a timer that continuously runs during the time of this lab, and you'll have 30 minutes to complete it. If you don't complete it in the time, you can come back and rerun it again. But you will have to start from the beginning. What this does is opens a project for you inside of Google Cloud Platform, and it gives you the resources that you need to run this lab, and it does so for free. Here's the username that you're going to log in with. You're not going to use your own Google account, because if you do, you'll incur charges. Click Open Compute Console, choose Use Another Account, paste in the username, go back to the previous page and get the password. When you do this, it'll start a project, and this is the project name that will be started. Accept the terms, and you don't have to do anything else, so just click Done. What opens is the console to Google Cloud Platform. Accept any terms that are needed. Look up at the top and you'll see the project ID that was created for you. Here's the project ID, and they should match. If they don't match, then that indicates it's something you somehow managed to log in on one of your other user accounts. So just go back to the previous steps and restart. Now, let's take a look. We're going to start with the tools. This is Cloud Shell, and we're going to activate it. It's a command line interface to GCP. It allows you to run command line operations instead of using the user interface, which you could have used the user interface either as well, but it's helpful to get more comfortable with the command line interface, because then you can script your steps and automate your processes. The first thing we want to do is recognize that we're going to start up a Kubernetes cluster inside of Google Kubernetes Engine. You could start your Kubernetes cluster on another set of machines, on bare metal, on your laptop, but if you do it inside of our hosted environment in Google Kubernetes Engine, then we'll handle the spinning up of the VMs for you, and we'll provide other resources such as load balancing and auto scaling and auto repairs and monitoring. So it's a very useful way to manage your Kubernetes cluster. What we're going to do is we're going to start a cluster, we're going to deploy a containerized application in it, and then we're going to work with the commands and the resources. The first thing we want to do is run gcloud auth list. And this will tell us at the command line level inside of this SDK who's the signed in user. And it should match the user you just signed in with. But we're just double checking. Then we're going to want to run gcloud config list project just to make sure that the SDK is working with the project listed above. Now we're ready to start our actions. The first thing you need to do is tell GCP which zone you want these resources, these VMs, to spin up in. So you're going to type in gcloud config set compute zone. I'm going to pick a zone in Asia because right now, if I were to pick a US Central or US West, it would take for quite a while for my cluster to spin up. So I just tried this a few minutes ago, and because so many people in the webinar are hitting the resources right now, it would have taken forever. I would have timed out. Now that my zone is set, this is where my VMs will spin up. So now I'm going to start and create my cluster. All you have to do is run gcloud container clusters create and give it a name. Now, it's going to take a few minutes. I'm going to talk about what's happening in behind the scenes. First thing is a Kubernetes cluster has two sets of nodes or VMs that's going to spin up. The nodes break down into two categories. There's the worker nodes, which run your containers, and there are the master nodes, which manage the worker nodes. And they provide the control plane. They receive commands from you as an administrator to install applications, to check for health checks. They allow you to set up load balancers in front of your applications. And they're the ones that also check the health of the nodes, make sure that they're running. If they're failing, then they restart the nodes and restart the applications that were running on them. While we're doing this, it's going to take a couple minutes. I'm going to show you what kind of resources are in place right now inside of GCP. First thing I'm going to do is I'm going to look at the VMs. Here you'll notice that it's spinning up the cluster is spinning up 3 worker VMs for you. One of them's already up and running, the other 2 are still working on it. If we go to the Kubernetes Engine cluster, we'll see that it's in the process of spinning up. Here's the number of nodes it's spinning up, the cluster size. Here's the zone it's spinning it up in. And if we were to go back to Compute Engine and look at the instance group, here's your list of this is an instance group that manages the 3 VMs that are starting up. Now we may have to wait for just a little bit more time for this to happen. I'm expecting this will come up. You'll see that your master nodes are now healthy. There was a check that was run just a minute ago, the health check, to see that the master nodes are coming up. They're reporting healthy status. And this will be a process that continues on throughout the operation of your cluster. Your master nodes will be checking one another. The reason that there are actually multiple master nodes that are spinning up because you want to have high availability and fault tolerance for the master nodes themselves. They're going to be distributed across different, you'll have to forgive me, it's either distributed across multiple zones or multiple regions for your high availability. And you can even define at the command line how many master nodes you want to use. By default, we start up 3, and we distribute them across different zones or regions. Now here's the name, this is the response you'll get back. Here's the name of the cluster. It's running in Asia. It's got an instance name to it. It's got a master IP address that you can hit to monitor and interact directly with the cluster master nodes. This is the machine type that was spun up. You can define different types of machine types for your nodes. That's not a problem. It's just part of configuration that you have to set up. All right, here's the number of our nodes, and here's their status they're running. Let's do a quick check. Go back to compute instance. Here are your VMs up and running. And if you go to the cluster under GKE, you can see that the cluster looks like it's still, there we go. It's showing full status. It's got its number of nodes reported. Now let's deploy an application onto, well, before we deploy an application onto it, let's configure the SDK to be able to communicate with these master nodes. And what we want to do is save a credential. We just want to get the authentication credentials from Kubernetes Engine. This will save the credentials within the SDK and allow us to communicate directly with that cluster. Now we'll spin up and run our application inside of the worker nodes of this cluster. We use kubectl, which is a client-based, it's a client that runs on that runs inside the cluster and allows us to communicate directly with the master nodes. And it's going to tell us, we're going to tell it to run an application called well, in parlance of Kubernetes, it's called a deployment, and it's a shell for your application. And we're going to pull an image of a container from our Google public registry. You can get access to this too. You'll run this in your own lab. We're going to use version 1, and we're going to, it's a web server, and what we're going to, in a container, and all we're going to do is expose port 8080 to that web server. Now what's happening behind the scenes? We're creating a deployment that is a representation of our app, our containerized app, and with that deployment comes certain resources that we can now use. Within a deployment, we install and run pods, and the containers run inside the pods. The pods are useful. We could have just, you would think, why not just run the containers? Well, the pods is a wrapper around the container that provides access to shared storage volumes and shared networking. So if you have a couple of containers you want to put into one pod that have a hard dependency, they can communicate with each other on their own local host. Imagine a pod now could be bounced around from machine to machine within your cluster, and you wouldn't even have to worry about changing the networking of the IP host or the IP address of the host. Now let's expose. We've got this pod running and listening on port 8080, but it's not exposed outside of the cluster. That's the way networking is set up by default inside of Kubernetes. So what we want to do is expose this port to the outside world so we can hit it with a web server and test it, or with a web client and test it. So we'll give a command, kubectl, to expose the deployment. Hello server. And what we're going to expose it with is a load balancer. This gets us a couple of extra advantages by using a load balancer. One, it gives us a public IP address that can be hit from my web browser and my laptop in just a minute. And two, it puts a load balancer in front of my pods. So if I wanted to run multiple pods for scalability on my application, I could set up auto scaling on my application. The pods would spin up, and they would all be serviced behind this load balancer, which has a fixed IP that remains stable over time. And the connection to Google Kubernetes Engine is, if we look at our services now, we have a service that's been spun up. This is around the load balancer. This is an object inside of Kubernetes. It's represented by a service. The type is a load balancer. It has a public IP address. The endpoint is not available just yet. It'll take a minute. And the other feature we have behind the scenes is in networking services on Google Cloud Platform. We've got a load balancer. And here's the load balancer. Looks like it's in the process of being spun up. Now let's see if we can hit the load balancer from outside. Let's see. Let's just do this. Let's run a quick kubectl get services command to check the statuses of I want to check the status of the service. It has its external IP address. Here it is. And this is what we're going to use. We say the web server now running as a containerized app inside of a pod has an external IP address that's available to the outside world, and it's accessible on port 8080, which is where we exposed it, and we get the response. It's a simple demonstration of how you've taken an image of a container that was pre-built, stored in a public registry on google.com, and now we have downloaded it to our, we have installed it inside of our Kubernetes cluster. It's running as a containerized application. It's got a load balancer in front of it, so we could spin up many different pods running this container and make it highly scalable. We can make it highly available. We can make it fault tolerant. We can set up health checks on it and liveliness probes to make sure that it's running and healthy. Let's go back. And all of the resources are being run in the cloud on GCP. So what I'd like to do is just wrap up. I'd like to thank you very much for your time. We have, in this demo, we've given you an opportunity to deploy a containerized application on a Kubernetes cluster using Kubernetes Engine. I hope you find that this is a very quick way to install and run scalable, highly scalable applications in the cloud. So thanks for joining me, and we'll have more live content coming up soon. so much for joining us for that great walkthrough.
Thank you so much, Jim, for that great walkthrough. Thanks so much, Jim, for that great walkthrough. Keep in mind that you'll be getting an email afterwards with information to access the Qwik Labs and the Coursera content. From now until the end of 2019, we are giving you 1 free month of access to developing applications with Google Cloud Platform specialization on Coursera. So take advantage of that.
Absolutely. I think we talked a little bit about how great that is and how you can kind of continue to use that after this conference or after this event to learn a little bit more.
Yeah.
And the sessions from this event should be available for on-demand viewage, hopefully within a week, so that you can kind of keep learning on your own and check out some of the other cool stuff. We talked about Coursera and how you can actually get certified, taking that training and then going through the official certification platforms so you can become Cloud Architect certified or Data Engineering certified. There's all kinds of great ways to keep learning that. And like Priyanka said, all of that stuff is going to be in the email to remind you about how to continue forward. So thanks everyone for joining us and for participating in the question and answer. Hopefully you found all this useful, and we look forward to seeing you at the next event.